Welcome back, class. We are on our last section of this chapter. So you guys said you like this style of notes. We'll continue it this way. As I said in the announcements this morning, we do have school on Monday. So I've pushed our test back to Monday. So the rest of this week, this is how it will go. Today we're doing lesson 10. Tomorrow you'll be given your test review and I'll tell you which sections to complete. And we're going to have a Zoom review session at 10 a.m. Friday will be your quiz over lessons 7 through 10, and then your homework will be to finish the review packet. On Saturday, we'll have another Zoom review session at 10 a.m., and then on Monday will be your Chapter 8 test. And just a little bit about my availability. I'm available to you guys from 8 a.m. to 8 p.m., okay? Pretty much every day of the week, even on weekends, I don't mind. But after 8 o'clock, please no calls, no texts. Miss Ayers does go to bed early. I have young children, and I wake up at about 4:30 to make all this happen, so to get my videos up. So just be aware of that. All right, let's get started. So today we're going to be doing the very last lesson, and so this is let me turn on my pen. Here it is. And so today we're going to complete lesson 10. Okay. Today we're going to be talking about box and whisker plots. And a box and whisker plot is a way to organize data into four groups or four sections called quartiles. Okay, so you'll notice here that you can see the four sections. So here is a quarter, 1, 2, 3. These are your defining points. And from there, you can see how this would be the first quarter, the second quarter, the third quarter, and the fourth quarter. Okay. The minimum value is the smallest value on your box and whisker plot, which is going to be this value right here. Okay. The lower quartile is the median of the lower half, the median of your lower half. And that is also represented on the box and whisker plot right here. Okay. So notice here that this line here leads us to our next definition of the median. This is the halfway part, the middle value. Okay, we discussed this earlier, this chapter, what the median is. So if I have the lower quartile is, notice here that this is halfway between the smallest and the median. So this is called the lower quartile here. Okay, and then I have an upper quartile, which is the median of the upper half. The median of the upper half. So everything to the right now is going to be the upper half. So all the way to here, which this here now is my upper quartile, which leads me to this very last point, which is your maximum value. Now, I know that these are not evenly distributed, meaning that notice here that this distance here is much longer than this distance here to the maximum value. And that's okay, because sometimes our data is not perfect. So we'll talk about that. Maximum value or the largest value here. Maximum largest value. Okay. And so again, these quartiles are the four sections that make up the box and whisker plots. Four sections that each represent 25% of the data. So think of that word quartile. It sort of sounds like quarter, right? So that can help you remember quarters are worth 25 cents, so 25% of the data, okay? And your interquartile range is the range between, and what you're going to do is you take your upper quartile and subtract that lower quartile value, okay? So I know that this is a lot of definitions, and so let's go ahead and look at an example so that we can get started, okay? Let's look at example 1. Oh, there we go. The box and whisker plot below represents the heights of a group of students. Give the 5-number summary, then answer the questions below. Find the minimum. The minimum is going to be your lowest value right here, all the way to the left, and this value, notice here, is 56. So the minimum height is 56 inches. Okay, the lower quartile comes next, which is this value here. Okay, this is your lower quartile is 60 inches. So that means 25% of the students are between 56 and 60 inches tall. Okay. Now the median, which is the half here represented by this line, is 64 inches tall. The upper quartile is this value here, 74 inches tall. And then the very last one here, I'll put upper quartile here. And here would be your maximum at 78. So the tallest person in the whole class is going to be 78 inches tall. Okay. So that's how you read the box and whisker plot. Okay. All right. What is the range? The range is going to be the max minus your minimum value. Okay. So the max is 78 minus 56. So you have a range now here of 22 inches. Okay. 22 inches. That means that your shortest person is 56 inches tall. The tallest person is 78 inches tall. So there's a range of values that are 22 inches. What is the interquartile range? Now, the interquartile range is just the middle 50%. So you take your upper quartile here and subtract your lower quartile here. So it's the upper quartile minus the lower quartile. Your upper quartile is 74 minus 60. So the middle range is going to be 14 inches. Okay, 14 inches. What percent of the students are between 56 and 60 inches tall? So 56 starts here, right? And we're going to keep going all the way till we get to 60, which is going to be this section here. Now remember that each of these values, the min, the lower quartile, the upper quartile, and the max represents 25%. That's why it's quartiles. So here I just have one group. So from here to here is one, 25%. From here to here is your second 25%. From here to here is your third 25%. And from here to here is your fourth. Okay, so we're only talking about, though, from 56 all the way to, oh, let me get my yellow pen here. We're only talking about here 56 through 60. Okay, so that is just 125%. So 25% of the students are between those two heights. How about what percent of the students are at most? Remember that word at most means less than or equal to 74 inches tall. So find 74 in your graph right here. And I want all the ones that are lower. Okay, notice how many quartiles does this represent? 1, 2, 3. If you have 3 25%, then 3 times 25 is going to give you 75%. So 75% of the students are less than or equal to 74 inches tall. Does the data vary more above or below the median? So what it wants you to do is look at this median value. The median is the very middle. Okay, right here, I'll draw a squiggly. Right here is your median. And does it vary? Mean, is it wider to the left or to the right? And to me, it looks like it's wider over here to the right. So it varies more above. Varies more above. Okay. All right, in this example, we're talking about the numbers of grams of fat in 9 sandwiches on a menu at a restaurant. So the very first thing you want to do in order to be able to find the median, remember the rule was they have to be in order. So let's rewrite our numbers in order. Okay, so 12 looks to me to be the smallest, 14, so we can rewrite them 12, 14, 16, 19, 16, 19, 22, 25, 28, 35, and 39. So we've rewritten now all the numbers. Let's make sure 25, 28, 39, and 35. Perfect. Okay, let's first start by finding the median. Okay, so remember we said to do that would be to come from each direction. So 1, 1, 1, 1, until you find that middle value. So we found it here. Okay, so your median is going to be 22. That's the very middle number. Okay, and then in order to find, I guess the next easiest ones would be your minimum, right? Your smallest number, and your maximum, which is the biggest number. So your minimum is 12, and your maximum is 39. Now to find the lower quartile and the upper quartile, you want to find the median of the upper and lower half. So here's the half mark, right? Here's the lower half, which go in this direction, and here's the upper half, which go in to the right in this direction. So first, let's talk about the lower quartile. Okay, so again, we want to go from each direction, but notice here that we have two middle numbers on the lower end. And so to find that lower quartile, what we're going to have to do is add them together, find the average. 14 plus 16 divided by 2. 14 plus 16 is 30, divided by 2 is 15. So the lower quartile here is going to be 15. In the upper quartile, again, go from each direction and find your middle values, which is going to be between 28 and 35. So you're going to have to add them together, 28 plus 35, and divide by 2. 28 plus 35 is going to give you 63, divided by 2, and you'll have 31 and 5/10. So you can have a decimal, that's okay. 31.5 is your upper quartile. Now let's go ahead and graph these. Okay, so notice here that my lowest value is 12 and my highest value is 39. So I think on my graph, I'm going to go by 5. So maybe I'll go 10 here, 15, 20, 25, 30, 35, and 40. You want to be able to fit all your data here. So this looks good. And let's go ahead and graph first the minimum value. So the minimum value is at 12. So that's going to be about here. It's going to be less towards the 10. So here is my minimum value, okay? And you could go ahead and graph your maximum value up here at 39. All right? Okay. So we've got here, we've graphed the minimum and we've graphed the maximum. Now you could also go ahead and graph your median, which is at 22. So somewhere about here. Okay. All right. Now we want to graph the lower quartile and the upper quartile. That's also where the box from the box and whisker plot comes from. So the lower quartile here is at 15. So draw your circle here. And then you can go ahead and draw that whisker that goes from your minimum value to that lower quartile. And then you can graph the upper quartile at 31.5, approximately here, and draw the whisker that goes from the upper quartile to the maximum value. Then in between your lower quartile and upper quartile, that is where you draw your box. So the box and whisker, the box comes from the interquartile range in between here, and the whiskers come from your minimum and your maximum. And then you should draw a line here down where your median is. So this is how you draw a box and whisker plot. Now let's look at some problems where we're going to interpret some information given some box and whisker plots already. So what's the median age? Remember, your median is where this middle line is. So median is here. And so the median age of teachers at Carter Middle School is 46 years old. What is the interquartile range? Remember, that's your upper quartile minus the lower quartile. The end of the box on the right side is the upper quartile. The lower end of the box is the lower quartile. So you take that upper quartile value of 54 and subtract your lower quartile of 30. 54 minus 30 is 24. So the interquartile range means 50% of your teachers have a 24-year age difference. What percent of teachers are at least 30 years old? Remember, when we're talking about percents, we're talking about 25%, quartiles. So are at least 30. So that means greater than 30. So come over here to 30, and we're talking about all of these values are here. So notice from the lower quartile to the median, that's 25%, plus another 25%, plus 25 more percent, because we're breaking this up into 4 sections, section 1, section 2, section 3, and section 4. So for each section is 25%. So 75% of the students are at least 30 years old. Let's look at one more. The 400-meter run times in a girls' track meet are shown below. Identify the minimum and maximum run times. The minimum is all the way to the left, and your maximum is all the way to the right. So you could tell me that the minimum is at 58 and your max is at 70. There's a bottle in there already. Okay. What percent of the runners had a time between 63 and 70 seconds? So here's the value 63 in between 62 and 64, all the way up to 70 seconds. So notice how many quartiles does this represent? From here to here is 1 quartile, and from here to here is 2 quartiles. So you have two 25%, which will be 50%. So half of the runners had a time between 63 and 70 seconds. What percent of the runners had a time at most means less than or equal to, so had at most 60 seconds. And so let's find 60, and we're talking about less than or equal to, so this section over here. So again, this is just one section, which is going to represent 25%. 25% of the runners. Okay. And the last topic, we're going to compare box and whisker plots, two of them. Okay, so notice here, this is a double box and whisker plot comparing two different baseball teams. So it shows how many number of runs are scored by the players on each of the teams last season. Which team has the greatest range of runs scored by the players? So the range is your smallest minus your biggest. So it will have the most spread out box and whisker plot. So which one has a wider box and whisker plot? Well, the Tigers do. Notice here that their maximum goes all the way to 36, which is greater than the Brewers' max, and their least minimum value comes all the way down here to 25, which is even smaller than the Brewers. So the Tigers have the greatest range. Based on the runs, which team has a stronger group of players? So stronger group of players here, then we're going to be thinking about, well, which group of players which team has the most players that score higher points consistently? So notice here that the Tigers, 50% of theirs scored between 26 and 32, right? So they mostly scored between 26 and 32 points. But the Brewers mostly scored between 29 and 32 points. So which one looks better to you? Would you rather have a team that consistently scores between 29 and 32 points or between 26 and 32 points? I think that the Brewers has a stronger group of players because they're more consistent in their higher scores. 29 is a higher value than 26 is. All right, so that's with box and whisker plots. If you're struggling with this, again, reach out to me, email, call, or text. I am here for you guys always. So I talked earlier about my availability, and so call me. Bye.